Namaste, I'm Saish Gandhi, founder and mentor of Legogoa Club. Robotic competitions are far more than just building cool robots to compete. They're a powerful platform for developing computational thinking. At Legogoa, I have seen firsthand how these competitions ignite a passion for learning. Students like Sai Pranav and Viraj don't just memorize facts, they actively engage with real world problems. They learn to think critically, collaborate effectively, and persist through setbacks. Team Legogoa has participated in many national and international competitions and won multiple awards.
Hi, I'm Viraj Vishwanath Marathe. What is computational thinking? It's a problem-solving process that involves breaking down complex challenges into smaller steps, finding patterns, designing algorithms, and iterating on solutions. For smaller kids, computational thinking can just be arranging the toys in a specific manner, such as keeping the small toys on top of the big toys. It can be organizing picnic, which involves planning the venue, the games to be played. And for us, it is participation in robotics competitions by building robots. For all the computer teachers, here is the simple diagram which explains computational thinking.
One of the robotics competitions which we participated in is called the First Global Challenge, which can also be called the Olympics of Robotics. Here, we represented India among 198 countries at the competition held in Singapore. As you can see, this robotics competition consists of several challenges which have to be solved by our robot in order to earn the maximum number of points. To participate in this competition, we had to build a robot that could score the most number of points. We started by analyzing and brainstorming the challenge to come up with several possible solutions. We then made sure that we had all the required materials and that our team members had the required skills to be able to build the robot. If not, then we would either buy the materials or attend workshops to train ourselves. We also divided our robot into different subsystems, such as the drivetrain, which would help in the movement of the robot, the intake, which would help collecting different objects around the field, and other mechanisms so that we could simplify the building process and help us to build the robot. After several months of hard work and skipping school, we were able to complete the robot. We were one of the best teams at the competition and were able to score many points. We reached the semi-finals and carried our India's flag onto the podium and won 4 different awards. Let me talk about one aspect of our robot, which is the drivetrain. The drivetrain is the chassis of the robot and it helps the robot to move forward, backwards, and in other directions. In order to make our drivetrain, we first researched existing models of drivetrains used by other teams. After researching, we found out about different drivetrain types such as omni-wheel, 6-wheel, 8-wheel, and other wheel drives. Then we used computer-aided designing, also known as CAD, to virtually design each model of our drivetrain and compare them. This allowed us to make different versions of the drivetrain and compare them without actually having to physically do anything. Through this process, we were able to finalize the 6-wheel drive. However, we had not yet decided on the wheel combination to use for our drivetrain. For this, we made a code on our robot which would run the robot straight, take turns, and simulate other situations which might occur normally in a match, and we tried this out with many different tires. The code would also actively take the current drawn by each of the motors and check the efficiency of each of the different wheels. This way, we were able to find out which wheel was the most efficient for our robot.
The process of computational thinking we use closely resembles the creative computational problem-solving model, also known as the CTiS model. In this model, we first understand the challenge, followed by brainstorming the ideas as a team. For example, it can be understanding the FGC challenge, which is just to pick up some balls. Now, we brainstorm some ideas on how we can pick up these balls efficiently. We first thought of different ideas for the intake, followed by the drivetrain, and finally, the storing mechanism. After these, the ideas are split into different subtasks, which can be done by the team members based on their skill sets. Then comes building and coding the prototype. After this, we evaluate the prototype. This stage is also known as evaluation. This helps us by giving us valuable insight onto what is going on the robot. If something goes off track, we can note that down and repeat this cycle. But of course, there are challenges in this journey. For us, being students, the biggest challenge is balancing our academic demands with these robotics competitions. Another challenge is an ever-changing team. This hinders the team dynamics, as a team needs to have good relationships inside the team so that the intercommunication and progress goes smoothly. And of course, as every team, we also have the challenge of every team member having his or her own unique skill set, which we need to put to use very effectively so that our team progress is very smooth.
In summary, robotic competitions are a powerful tool for cultivating computational thinking. They transform learning into a fun and engaging experience. These competitions simulate real-world technology industries, bridging the gap between the theoretical knowledge and practical application. To end, we would like to acknowledge all of these. Thank you.